Before you buy a 4K video projector, you need to understand what pixel shift is. I'm Elon Osborne, and this is Ecoustically Speaking. Video projectors are a great way to get that true cinematic experience at home, given that all movie theaters use projectors to display the picture. Today's projectors offer increased brightness, more accurate color, flexible installation, such as UST projectors, and all the inputs you need. A growing number even offer smart TV streaming features and built-in audio, although using an external audio system is the best option for that, obviously. However, despite all the advancements made in video projectors in recent years, one problem, especially when competing with the ever larger screen sizes of TVs these days, is how to incorporate 4K UHD or even 8K resolution display capability. Incorporating resolutions higher than 1080p is still rather difficult for a projector. TVs on one hand have a large surface that can fit the needed number of pixels to display high resolution. But although projectors can display very large images on a screen, the actual imaging chips that contain the needed number of pixels to display a specific resolution is extremely small, usually less than a 1-inch size rectangle. For reference, here is the number of pixels needed to display specific resolutions to give you an idea of how small the pixels need to be to fit on a less than 1-inch rectangular imaging chip. Squeezing the 8 million pixels needed to display 4K UHD resolution in the size of a video projector imaging chip is very expensive due to the required miniaturization and very precise manufacturing required. As a result, most video projector makers developed what they see as a cost-effective alternative that provides viewers with a similar viewing experience: pixel shifting. Just like the soap opera effect or motion smoothing feature on most modern TVs, pixel shifting goes by different labels depending on the manufacturer. For example, GVC uses the label E-Shift, Epson uses 4K Enhancement or 4KE or Pro UHD, and Texas Instruments informally refers to its system used in DLP-based projectors as TI UHD or XPR technology. Here are the essentials of how pixel shifting works. The most common starting point is that LCD-based projectors incorporate 3 standard 1080p chips. This means that at their core, most pixel shifting projectors are 1080p projectors. But they use pixel shifting to extend that resolution 2 or even 4 times depending on the model. When these projectors detect a 4K video input signal, such as from an Ultra HD Blu-ray disc, and select streaming services for that matter, they split the signal into 2 1080p images, each with half of the image information. The projector then rapidly shifts each pixel diagonally by a half pixel width and projects the result onto the screen. The shifting motion is fast, 120 Hz actually, which fools the viewer into perceiving the result as approximating the look of a 4K resolution image. This is referred to generically as dual pixel shifting. Since the pixel shift is only half a pixel, the visual result may be more like 4K than 1080p, even though technically there aren't that many pixels displayed on the screen. In reality, about 4.1 million visual pixels, or twice the number as 1080p, are actually displayed. Select Epson projectors such as the LS11000 and LS12000, as well as the Q-series projectors introduced in 2024, use quad pixel shifting. Instead of only shifting the pixels diagonally, they are shifted horizontally and vertically back and forth at the rate of 240 Hz. This process results in the display of 8.3 million pixels, which is a more accurate representation of a 4K UHD resolution. Texas Instruments provides 2 pixel shift options for use in projectors that use its DLP imaging chips that follow the pattern used by Epson in their LCD-based projectors. Starting with a 1080p resolution DLP chip that is 0.47 inches in size. Instead of shifting the pixels diagonally in one direction to achieve a 4K-like result, the pixels are shifted both horizontally and vertically. This results in the appearance of a more accurate 4K-like image as the pixels are shifted at 240 Hz. Instead of using a 1080p DLP chip, the Texas Instruments DLP chip is 0.66 inches in size, with 4.15 million pixels as the starting point. 4.5 million pixels is twice the number there is in a 1080p chip, remember? This means that the pixels only need to be shifted diagonally at a rate of 120 Hz. When the pixel shift process is implemented in a DLP projector using either a 1080p or 2716 by 1528 Ti DLP imaging chip, the projector sends out 8.3 million pixels to the screen. Just FYI, pixel shifting doesn't work for 3D viewing. If an incoming 3D signal is detected or motion interpolation is activated, pixel shifting is disabled so that the 3D image is displayed in 1080p. The pixel shifting process is so fast that it is almost like the pixels are in two places at one time. This isn't quite Star Trek transporter stuff, but the displayed results are actually pretty impressive, despite naysayers claiming that pixel shift is not 4K but faux-k. However, what is important is what the viewer actually perceives, and in reality, just as it is difficult to see the difference between 1080p and 4K UHD on a TV screen at average seating distances, it is even more difficult to see the difference between native 4K versus faux-k on a large video projection screen at an average seating distance. Of course, even though the vast majority of video projectors targeted for consumers use pixel shifting to achieve a 4K UHD viewing experience, there are consumer home theater projectors that do employ imaging chips that incorporate native 4K UHD resolution. Also, although JVC predominantly offers projectors that employ pixel shifting, or eShift, remember, they also offer up select projectors that have native 4K UHD resolution, like the JVC d-ila NP5. Pixel shift technology is also used to obtain an 8K resolution viewing experience. For example, JVC offers 8K video projectors using its eShift technology. In this case, 3 native 4K LCOS-based d-ila imaging chips are used as the starting point, and JVC's latest generation eShift process, called eShift X, is used to create the intended 8K display capability. On the surface, you might think that pixel shift and video upscaling are just two variations of the same thing, but here are the differences. This process increases the real resolution of a video projector beyond the native resolution of its imaging chip. This is done by doubling or quadrupling the number of pixels visible on the screen. This process increases the perceived detail of a video source that is lower resolution than the resolution of the display device. This is done by interpolating pixels between the real ones in the source to better match the native resolution of the TV or projector. Make sense? Good. Because that about wraps up this episode of Ecoustically Speaking. Now, do you know why a projector that produces a native 4K image is so expensive with those tiny little chips? But in the end, since it's almost imperceptible at normal viewing distances anyway, are you now more likely to want to save some money in the end and get a projector that uses pixel shifting tech inside? Let us know in the comments below. To stay in the know of all things projectors, home theater, home audio, hi-fi, wearables, gadgets, and tech, don't forget to bookmark ecoustics.com. Until next time.